Hello everyone, Kotongwane, the Nated God here. Right, we are still looking at relative velocity, but for this video specifically, we'll be looking at how we solve problems based on relative velocity using the parallelogram method, also known as the vector diagram method. Right, now if you've come across this video, it means you've already watched, or if you're watching this video, it means you've already watched the one that precedes this one, right, on my playlist for relative or for problems based on relative velocity, where I essentially do the same problem but using the method of components, right? So if you haven't watched that video, I have left a link on the description for this video, right? That link will take you straight to that video that I'm talking about, right? But if you're interested in knowing how to solve problems based on relative velocity using the parallelogram method, then you are in the right place. Right. Now, like I said, we are still looking at relative velocity, and with relative velocity, the one thing that you should establish is which of the objects that you've been given you are going to take as the object, and which one do you take as the frame of reference, right? And that you will get in the question. Right, before we get to the question, let us look at the statements. A fighter plane Q flies at 250 kilometers per hour east, while the velocity of fighter plane P is 210 kilometers per hour west, 53 degrees south. Right, now if you look at the question will tell us which of the two objects that we've been given we are going to take as the object, and which one we are going to take as the frame of reference, right? So the question is, determine the velocity of fighter plane P relative to Q, right? So P being our first letter means that object P we are going to take as our object, and object Q, right, the fighter plane Q, we are going to take as the frame of reference, right? So with relative velocity, that's the first thing you establish, right? Which are you going to take as the object, and which you are going to take as the frame of reference, right? So what are we looking for? We are looking for the velocity of P relative to Q, right? This is what we are looking for, right? Velocity of P relative to Q, meaning that P is the object, Q is the frame of reference, right? How does that help us? The object you then draw on the Cartesian plane, right? The object you will draw on the Cartesian plane in the same direction as the one that's been given for object P, right? And then the frame of reference, right? The frame of reference, which is Q in this case, you are going to draw on the Cartesian plane in a direction that is opposite the one that's been given for object Q, meaning that, so P is our object, meaning P we are going to draw in the same direction as the one that's been given, right? The one that's been given is west 50 degrees south, and then Q being our frame of reference, right, we are going to draw in a direction opposite the one that's been given. The one that is given for Q is east, meaning that we are then going to draw our vector Q, right, west, seeing that west is opposite of east, right? Now we are using the method with the parallelogram method, so we have to draw a parallelogram, right? So how we go about doing that, you have to use somewhat of a scale, right? Because the idea around using the parallelogram method, right, is so that you are able to establish, right, the quadrant that the resultant velocity is going to be in, right? The resultant velocity is the one that we are looking for. So the velocity of P relative to Q is the resultant velocity of the two objects we are looking at, right? So again, when they say determine the velocity of P relative to Q, right, that velocity is the resultant velocity of the two objects that we are essentially looking at, right? So with the parallelogram helps us in determining in which quadrant this velocity, the resultant velocity, or the velocity of P relative to Q, right, it helps us to establish in which quadrant it is going to be in, right? Hence, it is very important that you try to use somewhat of a scale in having to draw your vectors, right? Now we've already established the object as well as its frame of reference. The object here is P, right? So P, we're going to draw in a direction that is the same as the one that's been given, and Q being our frame of reference, we're going to draw in a direction that's opposite the one that's been given, right? Now, the easiest way of drawing this to scale, right, is by using this simple method, right, or taking this easy approach, right? If you look at both of our vectors, right, this one is 250, this one is 210, right? So the easiest way of looking at this is by simply dividing the vectors by 100, right? So if you divide both vectors by 100, here you get 2,5 and here you get 2,1, right? So essentially meaning that 2,5 centimeters is going to represent 250 kilometers per hour, and 2,1 centimeters is going to represent 210 kilometers per hour, right? But if you look at 2,5 and 2,1, they are too small, right? So what I tend to do is, if I feel like the measurements that I've come up with are going to be too small, then you simply multiply them by 2, right? So here you have 2,1. Remember, we divided both by 100. If you divide this by 100, you get 2,1, right? 2,1 centimeters, I feel is too small, so you multiply that by 2, right? So 2,1 multiplied by 2 is 4,2 centimeters, and 2,5 times 2, right, is 5 centimeters, which I think is okay in terms of measurement, right? Then what you do next is, now the platform I'm using, right, I have this ruler feature that has both the ruler, right, as well as essentially a built-in protractor, right? I do not have necessarily the protractor. You are going to be using the protractor, right? In using the protractor, right, we are first going to draw the velocity or the vector of the object, right? The vector of the object is west 50 degrees south, right? Meaning this is in the third quadrant, right? So what you will tend to do is you will place your protractor upside down here, right? Place your protractor parallel to this line, right? Obviously upside down, seeing that you want a measurement that's going to be in the third quadrant, and then measure from here, right, to somewhere there. So this would be 53 degrees. 53 degrees. So after having placed your protractor, right, after having placed your, what is this? Protractor, right? After having placed your protractor parallel to this line, right, you then are going to measure 53 degrees going in that direction, right? And where you have 53 degrees, that is where you're going to place a point, right? So say this point represents the 53 degrees, right? Now, as far as how long the line is going to be, right, what we did was we divided both the vectors by 100. For this one, we got 2,1 centimeters, right? 2,1 centimeters I've decided is too small, so I multiply both by 2. So 2,1 centimeters times 2 is 4,2, right? So that means if this is 43 degrees, I am looking for 4,2 centimeters. Should be something that's round about there, right? Doesn't have to be that accurate, right? So that's something that's round about here, right? 4,2. So this will be 4,2, right? Right, so this represents 4,2, right? That is headed in that direction, right? 4,2, and then the object, right? The object being object Q is 250 kilometers per hour. Remember, we divide this by 100, we get 2,5, and then multiply that by 2, and we get 5 centimeters. Right? Now remember that the object you draw in a direction that is opposite the one you've been given. Seeing that Q, as per the statement, is going east, opposite of that would be west. So we measure 5 centimeters. Right, we measure 5 centimeters. Right, we measure 5 centimeters. Right, this should be around here. Right, 5 centimeters. Right, and that is headed in this direction. Right, you have 5 centimeters. Right, so these are your two vectors. Right, you have your object and you have the frame of reference. Right, now you can complete your parallelogram. Right, in completing the parallelogram, right, now for me here it is going to be very easy. Right, I'm just gonna duplicate this line, put it right there. Now what you are going to do is, right, in completing the parallelogram, right, in completing the parallelogram, you have to draw this vector, right there. Right, in drawing this vector here, all you do is you draw a Cartesian plane, draw a small Cartesian plane at that point. Right, you measure 53 degrees. In fact, for this one, the most easy thing to do here would be to first draw this one. Right, let's do this. The most convenient thing to do here would be to first draw this one. Right, why? Because you know this one is parallel to the x-axis. Right, so no angles to be measured. Right, there's absolutely no angles to be measured. You can just draw a horizontal line that is 5 centimeters. Right, so you then draw this one at this point. Right, remember that this one is 5 centimeters. So you measure 5 centimeters from here to there. Right, and you should get this line. Right, once you have this one, then all you do is, once you have that one, then all you do is you essentially connect the two. Right, connect these two. Right, this one doesn't necessarily even need to be measured, because if this is 5 centimeters, then that will be 4,2 centimeters. Right, now these ones, right, make them dotted. Right, because essentially our vectors here are this one and this one. These are just copies of the two vectors. Right, so you make them dotted lines. Right, and where those two meet, where this one and this one meet, that is where essentially your resultant is going to be. So your resultant is going to be at that point. Right, going in this direction. Right, and there you have your parallelogram complete. Right, remember, like I said, the parallelogram method, what you are trying to establish is in which quadrant the resultant velocity is going to be in. Right, so we want to establish where this resultant is going to be as far as in which quadrant it is going to land in. Right, and we've established it's going to be in this quadrant, headed in that direction. Right, now to make things easier for ourselves, now what you do is you label. In fact, before you label your parallelogram, right, you first establish your angles, the angles that you're going to be using. Right, I'll tell you just now why it is important to establish the angles that you'll be using. Right, now at this point, we know this angle here. Right, the angle that we know is this one. Right, that angle is 53 degrees. Right, remember that object P is west 50 degrees south. Right, west 50 degrees south. Right, so this angle here is 53 degrees. Right, but the way we use the parallelogram method is, once you've established your parallelogram, right, and you have drawn your resultant vector, which in this case is this one, the green line, right? That's your resultant vector, right? What you essentially have now are two triangles, right? You have this triangle, right? And you have this one. Let us label this thing, call this A, call that B, call this C, call this D, right? So you have two triangles, ABC as well as ACD, right? Hence, even though we know the magnitude of this angle, we cannot use it because what we've done essentially is split these two into two equal parts, right? In fact, we are not even sure if this here is equal to that, right? That is why we cannot use it, right? Because as much as we know this whole angle, but we do not know, right? We do not know the magnitude of this one or the magnitude of this one. You only have this whole angle, right? But what we can do is taking the fact that this is a parallelogram, right? It means that if you look at this from this perspective, right, this angle here, right, this angle here, right, and this one are what are co-interior angles, right? So meaning that if you know this angle, you'll be able to get this one, right? Seeing that these two are co-interior angles, and co-interior angles are equal to 180, right? So to get this angle, you simply say 180 minus this angle, right? So remember, we've established that this angle is equal to this, this angle, right, and this angle are co-interior angles, so meaning that they add up to 180, right? So if you have one, then you can get this one. And how you get this one is by saying 180 minus this one. This one is 53 degrees. So essentially you say 180 minus the 53 degrees, right? And you should get 127. So this here is 127 degrees, right? So we've established that angle, right? So this angle is 127 degrees, right? Now this angle is a part of triangle ABC, right? So we can use this angle, right? Or if you decide to use triangle ACD, right? Remember, seeing that this here is a parallelogram, the opposite angles, right, are equal, right? So meaning if this is 127 degrees, it means this here is 127 degrees. If this whole angle is 53 degrees, it means this whole angle is 53 degrees, right? Either way though, you first have to establish the angles that you will be using, right? And for this case, we do not necessarily use the angle that you've been given, right? Seeing that the angle that you've been given, right, represents this whole angle, and we cannot use this whole angle, right? Because once you've established, or once you've drawn your parallelogram, right, you then have to you then essentially split it into two, right, having two triangles, right? So meaning that seeing that we do not necessarily know the magnitude of this angle alone and this angle alone, we only know the whole angle, right? We then use co-interior angles, this angle being co-interior with this one, right? And we simply subtract this angle from 180 to get this one, right? Right. Now, why is it important to establish angles? It is important to establish angles because in using the parallelogram method, right, we either have to make use of the cosine rule or the sine rule, right? Now, the cosine rule, we use if the angle that we've established, right, if the angle that we've established is essentially an included angle, right? And if the angle you have isn't necessarily an included angle, then you cannot use the cosine rule, but you can make use of the sine rule, right? So if the angle that you've established is an included angle, then you can make use of the cosine rule or the sine rule, right? But in using the cosine rule, we are only able to use the cosine rule if the angle that we've established, right, is an included angle. Now, what is an included angle? Essentially, what an included angle is is an angle that is included between two known vectors, right? So if you have an angle, right, and that angle is between two vectors that we know the magnitude of, then you can take that angle as an included angle, right? For instance, if you look at this angle here that we've established, right, this 127 degrees, right, is it an included angle? We then look at the vectors that it is between, right? It is between this vector and that vector, right? Now remember that this here, right, P is 210, this here is 210 kilometers per hour, right? And this one here is 250 kilometers per hour, right? And then of course this here is equal to that, and this is equal to that. Now, included angle, right? I said the included angle is an angle that is included between two known vectors, or between two vectors that we know the magnitude of, right? So if you look at this angle, it is between this vector and this vector. We have the magnitude of this vector and we have the magnitude of this vector, which makes this angle an included angle, meaning that we are able to use the cosine rule, right? Aside from the cosine rule, we are able to use the sine rule, right? But remember, with the sine rule, you need two angles, right? And at this point, we only have just one angle, right? So it will be convenient for us to just use the cosine rule, right? Once you've established that, right, remember what it is that we're looking for. We're looking for the resultant. The resultant is equal to what we are trying to determine, right? So the velocity of P relative to Q is the resultant of the two vectors, and the resultant of the two vectors is this one here, right? So in using the parallelogram method, right, either using the cosine rule or sine rule, we want to determine this vector, the resultant of this parallelogram, right? And since we've established that this angle is an included angle, we are simply going to use the cosine rule, right? So using the cosine rule, right, we are going to use triangle ABC, right? So you then say in, right, you can either say in triangle ABC or simply say in ABC, right? So this here is the same as saying in triangle ABC, right? Of which at this point you should know that, right? Right, so in triangle ABC, right, we are going to be using the cosine rule, right? You give the sides names, right? So opposite angle B, you have side B. Opposite angle C, you have side C. Opposite angle A, you have side A. So what are we looking for, right? Now this is how you use the cosine rule, right? What are we looking for? We are looking for B, right? So you first write what it is that we are looking for. We are looking for B. So you say B squared is equal to, right, the other sides, right, are A and C. So this will be A squared plus C squared, right? Then you say minus 2AC, right? So minus the two sides, or the multiple of of these two sides, not the multiple, the product of these two sides. So it's A squared, so it's the one side squared plus the other side squared, minus 2 times the product of the two sides. So the two sides are A and C, right? Times cos, which angle? The angle will be determined by what it is that you're looking for. Since you're looking for B, the angle is going to be angle B, right? That is essentially how you write down the cosine rule, right? I shouldn't be teaching you this. This was done, I think, in Maths N3, right? But either way, this is how you do it, right? So now you substitute. Now all you do is substitute. So you have B squared is equal to A squared, right? Side A, here's side A is 250. So this here is 250 squared plus C squared, side C. Here's side C is equal to this one is 210. So this is 210 squared minus 2 into side A, which is 250, times side C, which is 210, times cos B. B is 127 degrees, right? Now, I don't need to say that you need to make sure that your calculators are in degrees, right? Not radians. Right. And then you get B squared, right? Now, if you punch this whole thing in your calculators, you are going to get, right, in fact, what you are going to get is 169,790,577, right? That is what you should get approximately, right? That is definitely what I got, right? So we are looking for B, right? Then you apply the square root both sides. So obviously that goes, right? You write down your square root this side, right? And then B will be equal to the square root of this will give you 412,057. Remember, this is in kilometers per hour, right? Remember that B represents the resultant here, and the resultant is equal to what we are looking for, right? So the velocity of P relative to Q is essentially equal to the 412,057 kilometers per hour, right? Now, our resultant has both magnitude and direction, right? Remember, I said the easiest way to remember how to get your direction is you always reference the angle from the x-axis, right? So if this is the resultant, we are going to calculate this angle here, right? We are going to calculate this angle, right? And this angle in triangle ABC, right, that angle is angle C, right? So we are going to calculate angle C, right, seeing that it is measured from the x-axis, right? It makes things easier if you do it like that, right? It is not wrong to calculate the angle that is measured from the y-axis, right? That is absolutely fine, nothing wrong with that, right? But I'm saying it just makes it easier if you're going to stick to referencing the angle from the x-axis, right? This is just advice, though. You can do essentially whatever you want to do, right? It's fine, right? Right, now let us calculate this angle here, right? So we are going to calculate this angle using the sine rule, right? We are looking for essentially angle C. Now with the sine rule, we are looking for angle C in the same triangle, right? So we say we're looking for angle C, right? The sine rule is we're looking for angle C divided by side C. This will be equal to the angle that we have, right, is angle B. So angle B divided by side B, right? Now if you look at this, this is what we're looking for. We have side C, we have side B, we have angle B, right? So in getting sine C, right, you essentially multiply to get rid of this here, right? To make sure that we are left with sine C, you get rid of C by multiplying both sides by C, right? And then essentially you'll be left with sine C is equal to C times sine B divided by side B, right? And then of course we are looking for angle C, right? So to have C as our subject here, right, you'll have angle C is equal to, this will be equal to the arc sine of side C times sine B divided by side B, right? This is exactly what we are looking for. Now all you do is substitute. So you have arc sine of side C, right? Side C, what is side C equal to? Remember, side C is equal to 210, right? So this is, okay, this is 210 sine B. Remember, B is 127 degrees. So this divided by side B. When you calculated side B, we got 412. So this is 412, comma 057, right? Right, now if you punch this in your calculators, you are going to get 24,017 degrees, right? So this angle here, right, this angle is 24,017, right? It's a reference from the x-axis, right? That we can tell from the parallelogram that this angle here is a reference from the x-axis, right? Right, then we can say, therefore, the velocity of P relative to Q, which is the resultant here, remember, the resultant is, the magnitude thereof is 412,057 kilometers per hour. Direction, right? Our angle is a reference from the x-axis as per the parallelogram, right? This is where our resultant is. As far as the x-axis, the resultant is headed west, right? So we then say we reference our angle from west. So this is west. The angle is 24,017, right? The resultant, right, is west. Seeing that our angle is a reference from west, meaning that this is west 24,017 degrees south. Right, so you have here, you have south, right, and that becomes your answer, right? This is essentially how you go about solving problems based on relative velocity, right, using the parallelogram method. Very easy stuff here, very easy, right? Hopefully this helped, right? Remember to like the video if you did like it, right, and subscribe to the channel so that you don't miss any other content that might be helpful to you, right? All the best.